Hey there, I'm Greg /Hanger Queen, and welcome back to the channel. I know it's been a really long time, well over a month now, since I published my last part 6 of the grinder. So this is going to be part 7, and I'm sorry for the very long delay. We're actually away on vacation for quite a while in the south of France, and I didn't want to publish that up front. I don't think it's a good idea to tell the whole world that you're going to be away, leaving your house empty. But we're back, and I'm back at it. I've been out here in the garage with the air conditioning on, working most every evening, and I hope to show you what I've got done here now. The brackets, the main table part, pretty much completed. So here, let me assemble it all for you. It's at a real time, show you what I got. I can get this back focused on the machine here. So there's the main arm, attachment arm they call it. The only difference I've done here is I put these grooves in at 90 and 0 degrees for the horizontal and vertical. Oh, and I also put a third ball. There's spring plunger balls in the inside here on the top that ride in these grooves. I put a third one in because the table is just so heavy, it wants to turn this thing around. So with it like this, it works pretty well. So I built this clamp. Oh, in Phil's design, he actually threads this rod and threads this piece and screws them together. I instead turned this 1.5 inch down to 1 inch inside here, used retention compound and a bolt through it. I think that's actually better, sturdier, and I can take it apart if I want to. So that's that part. Get it back in there again, come on. They're all tight tolerances, so they're kind of hard to get in. Then this is the table supporting arm. This goes in here and can go up and down to adjust the height of the table. And it can flip side to side if you want the table on this side or that side. Now, a little change from Phil's design. He normally keeps in his vertical position, his rod out this way, and then he swaps it around to do the horizontal. I find with a long enough rod here, I'm going to pretty much always leave this in this position. Oh, this nice tight fit here, like down to 1/1000 here, so it keeps this absolutely square to the platen when the platen's done. And then it's got a clamping action there. Let me tighten these guys up a bit so I don't move around. And then that holds the table bracket, which is this piece here. Now I did this with the boring bar in my mill rather than doing it in the lathe. This piece was just a little too big when I started to get it in my lathe without hitting the channels on the lathe. So I did the boring bar and I overshot. This is about 3,000 oversized, and I experimented with some shims in here, which actually kind of worked. But I'm going to instead, I have to remake this bar anyway because I screwed this one up pretty badly. This was my big mistake. I got one nice channel cut in it, and then when I cut my second one, the bit was obviously pretty dull, and it's just not a very good channel. And then the third one, the whole part slipped in the vise, so I totally mangled it up. So I'm going to completely remake this bar. I've got it on order, and I ordered 1 1/8 instead of 1 inch, so I could turn it down to fit precisely in here, like 3,000 oversized to fit in here. So I don't have to remake this part. And then I also bought some carbide ball mills rather than the old high-speed steel I had, so that I can get some proper cuts in the stainless steel here. Anyway, I found that by cutting this out, putting this little notch in here, I can get plenty of clearance, plenty of, oh come on, enough room out this direction. So my belt's on here. Let me put the belt on. So you've seen all this work before. Oh, in the lowest position for that. There we go. So there's the belt on in approximately the right position. And then this attachment arm slides in and out and locks in place. Again, there's still a platen to build from behind here. So that's it in the vertical position, all tightened up. Oh, as I go to move this in the horizontal position, the first time I did this, I didn't have this clamp tightened down well, and this whole thing slid right off the end and missed my foot by about less than 1/2 inch. It would have been very, very, very painful. So what I did as a safety feature is I turned down a couple of brass little screw-in guys here that I can thread at the ends of these rods, so I can put these in there to keep them from falling out and hitting on the foot if you make a stupid mistake. Come on, get in there. So there we go. So this thing can't fall off the end now as I turn it in the other position. But if you think ahead, before you turn it over, what you really should do is turn this way first, then turn it into the horizontal position, and then you can slide this down, and at its furthest extent here, it's perfectly centered in between these, in between where the platen will be. And then of course I can adjust it in and out with that adjustment and tighten it up. Oh, and then this guy here adjusts the height and horizontal, vertical. Oh, and I've also arranged, I didn't show you, in the vertical position, I'll go back over there, I flattened this out here to contact the bottom of the table perfectly, to keep it perfectly square in that vertical position. So I guess that's about it. I've got about 25 hours worth of machining this thing. And obviously I'm not going to show you all 25 hours. It's a lot of this monotonous kind of, usual cutting off, squaring, and then cutting the features in. I'll just show you a few of the highlights and a few of the mistakes I made along the way, and a few of the changes I made along the way to Phil's design. So that's about it. I'll get to editing my footage, and hopefully I'll get this thing published pretty quickly. So I started off this part of the project, as I often do, by cleaning up my mill table, give you a nice vacuum and light stoning, and then retramming using this SST tool that makes life easy. Get everything all squared up there, ready to go for the next phase of this project. Then into making the grinder table itself. It's a 3/4 inch piece of mild steel that I'd cut off earlier. About 6.5 inches wide with one very rough cut edge there, so I couldn't really put it in the vise. So I mounted it directly to the table on these 1/8 inch standoffs, so I can mill the edges without hitting the table, of course. Clamped it down, trued it up with the one good edge, and then milled that edge, and the front edge with the roughing, and then the finishing one. Now, while it was clamped down here, I also milled these channels. These are going to be for T-slots, and I'm making them the same width dimensions as the slots in the mill table, so I'll be able to interchange hardware. That's the plan anyway. Here I am mounting the vise again, getting it trued up. Now I can get the table in the jaws with the jaws extended, so that I can true up those ends. And then I fly cut the top surface nice and smooth. Now here you can see my table, my vise is contacting the rear of this thing. And so this little side project here I decided I had to do finally, meaning to do this for a while, is just to cut a little bit of the bottom of this post off, so that the back of the vise, that rear extrusion of the vise, can clear underneath that spot. It's quite a lot of work actually. This is greatly sped up, of course. You get about 3/4 of an inch of that hunk of metal off there. It's all a big solid chunk of metal. Cleaned it up with some files here. And then gave it a light painting to make it match again. Trimmed off some length of that accordion material because it doesn't need to be that long anymore rather than shortening things. Remounted the little bracket to that accordion material. And then cleaned things up and greased them up again here on the vertical post. Marked the new holes for the bracket, and drilled them and tapped them, of course. Mounted that bracket about 3/4 of an inch higher from where it used to be, and then the bottom piece is just as it is, using the original holes to protect the bottom. Now I can get back to the table again. So now I've got the extra clearance here, so I can do this fly cutting here of the top surface without any interference, which is nice. And now I'm doing the bottom surface. It's nice and smooth. While it's here, I decided to chamfer all the way around. Both sides, of course. Now here's into cutting the T-slots themselves. This is slow going. Here I'm just center finding on that slot. Greatly speed this up here because it's quite a slow process to get these T-slots cut through this metal all the way down. The first time I ever cut a T-slot. Went well, thank goodness. Flipped it around, trued it up, and cut the other T-slot. It's nicer going side to side rather than front to back, because then I can use my power feed. That's how slow it really goes in real life. And then chamfered those edges very lightly. And now I just need to make those 3 brackets that hold the 1-inch rod and the 1.5-inch rod. So I got this huge hunk of 2x4 steel delivered yesterday. I can't even pick it up with one hand, but basically this is going to be my L-shaped bracket, where on the end is that 1.5 inch. So it's going to mate up with the end of the grinder arm here, and then it drops down a little bit, and I can adjust how much drop down I need once I get the other 2 parts made. So I'm going to work backwards from the table. I'm going to make the table attachment part, which I'm going to make out of this big hunk of steel. I've sort of just X'd off roughly how it's going to be. There's no, super need for accurate dimensions here. Just I want it to span this gap here, and it's going to have flanges all the way around, and then a narrower section here in the center that's actually going to have the 1-inch rod go through and clamp on. So here we go. I'm just going to use my bandsaw to cut this off and get making this piece. So after cutting off a hunk of steel in the bandsaw, move it over to the mill and square up all the faces as usual. And I do some edge finding on it and center finding so that I can locate that 1-inch hole bore location. And I mark that location on the piece of metal and take a picture for posterity in case I need it. And I drill in steps a little bit at a time, all the way up to my 5/8 drill size, which is the largest I have, shy of 1 inch. Then I use a boring head on the mill to nibble away at that a little bit at a time, being very careful. It's quite tedious work, measuring very often as I got larger and larger, inching up on the 1 inch. And in the end, I managed to overshoot it by 3 thou. Damn it. So I soldiered on, thinking 3 thou is not that terrible. So over in the bandsaw, I cut out the corners to form the flanges in this part. Horizontal and vertical, use the bandsaw, portable bandsaw to finish up. Over to the mill and squared things up as usual. I've got some flanges. Then I did some edge finding and locating so I could drill 6 mounting holes in this part, 3 down each side. And of course I recorded the DRO positions because I need them to drill the holes in the table corresponding. Recess those holes so the cap screw heads will be flush as they need to be. Mounted at 45 degrees so I could put a nice thick chamfer on the 2 edges, but I left the a boss in the center where the lever is going to go, just for appearances. Then cut the slot down the center for the clamping action. And I drilled the tap size and the clearance size hole for the lever to go in here, tapped it appropriately. Now in order to compensate for that 3 thou overshoot, I tried using a ball nose end mill here to remove some material from the base of the clamps there at the corners to try to make them more flexible, as you can see here. And I also put it back in the mill and trimmed down the thickness of them a little bit, again to try to make it a little more flexible, and finally used a ball nose end mill to put another groove for flex. So now to make that relatively simple block that transitions the horizontal and vertical rods for the table. Here I am squaring up the block to begin with. And then I'll edge find and center find to get the 1-inch hole through the center here. Now I go up to 5/8 inch progressive again. I'll finish up on the lathe in a moment. And the other edge, it gets a 3/4 inch hole through here, which is going to hold the other rod clamped in place permanently. So again, I go up to 5/8. Now here it is over to the lathe using the trick where you use a dead center in the 4-jaws chuck there to get it all screwed up. Get it within a 1,000th of turning here to the center. And then I can use a boring bar in the lathe to bring that hole out to 1 inch. And again, I have to get this very close to perfect here, and I do. I nail this one finally. It's so much easier than using a boring head. So there is indeed a perfect fit. Yay me. Now the other hole just gets turned out to 3/4, and it doesn't have to be all that accurate, honestly, because I can whittle down the rod to suit whatever size I get there. I center finding again so that I can cut the hole for the lever, drill it out and tap it. Doing this in a different order. This time I'm drilling and tapping first, and then I'm going to cut the slot and then do the clearance hole. Doesn't really matter which order you do them in. 6 of one, half dozen of the other. So here I'm cutting the slot, So now moving on to that large beefy L bracket. Of course, I cut off a big chunk of metal first out of that 2x4 that I had marked up earlier. So it's now the next day, and I'm ready to square up the L-shaped bracket for the main mount there. Before I do, I just want to show, just as I cleaned up the mill here this latest time, I finally got around. I used to have magnets on the back of these things to hold them on, which is a really bad idea around a mill. Of course, they collected all sorts of crap, so I just put a couple of wood strips in there that will slide into the channels there. So they're held nice and securely, and I've got one on each side now, which is nice. Okay, I'm going to get on to milling this thing into square, and then take it over to the lathe, and as usual, put my holes in where they need to be. So once again, I have this over the mill and squaring it up, as per usual. Then I die-chemmed it and scribed some lines on there. I want to cut the corner out of to make the L shape. I did some center finding so I can locate that 1-inch hole, and then progressively drilled that to 5/8. So here I have that big block in my lathe dialed in pretty closely, sitting on 3 of the landings, 3 jaw landings, and the 4th one had to be reversed to hold onto it in this very imbalanced position. It just barely clears. I got lucky, it just barely clears my DRO scale down here by like 1/16 of an inch. I got very lucky there. Ideally, this DRO scale would be on this side, and you know, when I first put this thing on there, I thought about it, but unfortunately the Gibbs adjustment screws are here, so if I was to put it on this side, I'd have to have some way to get at those Gibbs screws, maybe lengthen them, I don't know. Anyway, I say I got lucky here right now that I can clear that so I can get my boring bar in there. I've got to go in here 1.5 inches for that hole, and that's going to get cut away afterwards. So 1.5 inches deep on my hole of 1 inch diameter. So I'm a little worried this is going to be horribly unbalanced. We'll see how badly it shakes. But it is what it is. I might have to do it with the boring head on the mill, but we'll see if I can do it this way. And so here we go again with the boring bar in the lathe, nibbling away at this hole just a little bit at a time. Trying to get a precise 1 inch, using the DRO for the most part, but also those expandable precision hole gauges. And I got lucky and nailed this one again. That's 2 for 3. I'm happy. And I cut that 1-inch rod to length for the horizontal, and what's left over is plenty for the vertical. I'll trim it later. On the L bracket here, I also did a 1-inch hole for the attachment arm. And I just use a 1-inch drill here. It doesn't have to be precise. Then I cut the L shape out of that block finally, on the bandsaw mostly, finishing up with a portable bandsaw. And then over to the mill, I clean up those edges. I can put the 1-inch rod in there with the 90-degree block to I want to get a very precise measurement here against the L bracket to keep it at, you know, very tight tolerance there. So I scribe it off there first, and then I mill down to almost that line while continually checking it with the 1-inch rod and that 90-degree bracket to see how it fits, nibbling away just a little tiny bit at a time as I go. And then I found out as I got one side, the larger side of the block proper, I ended up having to take just a little smidge off the 90-degree block as well, because that hole wasn't perfectly centered. And finally, my smallest ball nose end mill relieves that inside corner radius. Now for a bunch of fiddly steps to get these pieces assembled. I drilled and put some roll pins in all 4 of these lever arms to hold them securely. And then I painted them up a little later. I found the center of the hole for the 90-degree so that I could countersink that. This actually gets a bolt, not a lever, to hold that rod in place. I took a 45 off that L bracket just to make it look prettier and lighter, and then smoothed up the surfaces again and chamfered the whole thing to make things look pretty. Here I am taking the end of the 1.5 inch attachment rod down to 1 inch to fit that 1 inch hole that I drilled. And I'm measuring this thing precisely, of course, to match that hole size that I drilled, not bored. And similarly for the 1 inch rod, I took it down to 3/4 to fit that 3/4 inch hole that I had bored in that 90-degree block. So that fits nicely. And then that's going to get drilled out and bolted in place. I used retention compound and a countersunk and tapped cap screw to hold that in place. And I cut off the excess of the attachment arm here. I want to get a nice flat surface here on the top of this rod that's going to sit on the bottom of the table, so that in the 90-degree position, the table bottom can sit on the top of that square surface and support it in a perfect 90 degree. Then I center fine in that attachment arm, getting ready to cut the groove down the center of this thing. This is what those plunger balls ride in to keep it at the 0 degree position and 90 degree position. So here's the 90 being cut in here. I cut the slot in the L clamp for the clamping action. I stupidly forgot to drill and tap it at this point. It cost me a little trouble later on. Here I am drilling and tapping and countersinking the hole that's going to hold the bolt in to hold the attachment arm into that L-shaped bracket. Same way I did it for the 90-degree bracket. Tapping the hole there and then putting the socket cap head screw in there flush. So there it is, attached. And here's where it caused me a bit of a problem. I forgot to drill the lever arm here, so I've got this hung way high out. I've just got just enough reach out of my mill on this and using my stubby drills and so on. Well, it worked, but it was just more work than it had to be. And then testing the fit of the 8mm lever arm. As I say here, I come back later and upgrade these all to 10mm to get some better leverage action. Now back on the mill, I'm using that L-shaped bracket to round over the corners of the top of the 90-degree block and the rod, so it's a nice circumference there, matching the rod, where it's going to ride. The idea is here I want this to just barely touch the bottom of the table, which will give it some support when it's on an extended position. So that's a very close tolerance to the bottom of the table. So we have our table and our table clamp. Let's get them put together. Here I just put them together with temporary clamps to try to figure things out, or exactly where I wanted to affix it to the bottom of the table. And then I located those punch marks on my DRO on the mill and drilled them out. Now I've got the positions recorded from when I drilled the table bracket itself, so I just copy them over here from that home position. And I know they're going to be good. Love DROs. And I tap them out with a regular tap and then a bottoming tap because they're pretty shallow. I'm cutting off a bit of excess material from the bracket itself. I figured if I cut off as much as I can here, I can get a little more stick out of the table when it's in the vertical position to the right. So I'm going to take about a little over 1/2 inch out of this flange here to give me 1/2 inch more travel to the right of the table. Here I'm cutting a notch out of the flange of the bottom, then back in the mill, cleaning that up. You'll see what this looks like in a moment. Now I need to get a ball plunger in the center of this table bracket that's going to ride in a groove on this 1-inch rod that's going to be cut soon. So center finding and then drilling and tapping for that 12mm plunger. Phil actually uses an 8mm, but I upsized to 12 here to give it some more strength. Now you notice the plunger is going to stick upright, a little proud of the table bracket, so I need to cut a little indent into the table itself at the same position. And it fits well. As I mentioned in the introduction, I could have easily broken my foot as the table fell very close to it in my early testing of the thing. So these are just going to be some brass knobs that slip onto the screw into the end of the rods, the table adjustment rods, so they can't, the table can't fall off the end. So they're very simple little brass knobs here that I've made 100 times. That's just 10mm thread with the ELS. Very easy to do. Not very wide. And then I part them off. But before I do, I put a little groove in here, chamfer, and then part it off. And then I flip it around in the collet chuck and face it off. Then I put some little decorative grooves here in the end sort of matching the theme of the rest of this. It's little grooves 1/4 inch apart. So here I'm squaring off the end of one of the rods in the mill. This would have been a whole lot easier and better to do in the lathe, but I'd already mounted the rods into the brackets, so can't do it anymore. Then finding the center using my scratch technique, very simple, and drilling them out for the tap size, and then tapping them out to 10mm to fit the threads that are already on the knobs. Just a deburr and a blowout, and then a test fit. One of the knobs works just fine. And then of course I made a second one and did the same for the second rod. So early you saw me successfully cut 0 and 90-degree grooves in the main attachment arm. Now I need to cut 0 and 45s on each side of this table support arm. And it started out fine, doing it like this in this sort of a little bit of a janky setup in the mill. This again would have been so much better if I'd done this before I mounted the rods into the brackets. But there you go. The bits are getting kind of dull at this point. They're only high-speed steel, and they just got a bad cut on one of these surfaces, and then the rod actually turned around in the vise, so I pretty much ruined my job. It's scrapped now, and I'm going to have to remake this. I'll do it off camera later. Phil's plans call for 8mm clamping levers, and that's what I used, but after some thought I figured I'd upgrade them to 10mm to give some more longer handles and bigger threads to get some more clamping pressure out of these. So went through and re-drilled and re-tapped all those bracket parts I made earlier, and then made 4 new levers and put the roll pins in there and painted them up in the 10mm size. And while I had everything apart, I decided to put another 12mm ball plunger into this main attachment bracket to get some additional strength there on that attachment arm. So this will be the center finding, and then drilling and tapping and putting the 12mm ball socket in there. So recall this main attachment part has 2 levers on it. I thought it'd be kind of cool to stagger their height, make one taller than the other so the levers can pass over each other without interference. So that's what I'm doing here. I'm just making a couple of small bushings, one very thin and one quite a bit taller, for those levers to ride in to stagger them at about 1/2 inch or 3/4 inch apart. And here's the picture of them staggered. So that brings us to the end of part 7, and what's going to happen for part 8? Well, back to Phil's Fusion 360 plans here. I plan to make this platen, very simple part, and the platen attachment bracket, so I'm going to make it a little different out of some angle iron there. And I also have to redo that rod attachment arm that I messed up so badly in this build. So I'll do that do-over. And then I'll start finishing. I think I'll start painting and bluing and powder coating some parts here and start making it finished. So I hope you'll join me for part 8. Subscribe if you haven't already, and thanks for watching. Bye for now.